In this video, let's have a high level look at Open Language Model or OLMO from Alan AI. So this is a state of art truly open LLM and framework. Why is it truly open LLM? Most of the models which are released currently as open source in LLM, they just release the weights. Okay, for example, Mistral, they have just released the weights. So they are open weight LLMs and not truly open large language models. So OLMO and framework includes full pre-training data, the training code and model weights, and the evaluation suite. So they are releasing all these things, right? So each model comes with the following. So they are releasing 4 model weights for 4 model variants at the 7 billion scale, each trained on at least 2 trillion tokens. Their training data set called DOLMA has 3 trillion token open corpus for language model pre-training, including code that produces the training data, right? So that is their, they are releasing this data set. So if you look at what each model comes with, it comes with the full training data, it comes with full model weights, training code, training logs, training metrics, okay, in the form of weight and biases, logs and inference code, 500 plus checkpoints for every model, per model for every 1000 steps during the training process, evaluation code under the umbrella of AI tools, Catwalk and Paloma, fine-tuning code and adapted models which will be coming soon using with OpenInstruct. All code, weights and intermediate checkpoints are released under the Apache 2.0 license. That means you can use it for commercial purposes, right? The model, the code, weights and training code as well. Okay. So what is the advantage of doing this full open source or full open large language model? Now this provides researchers and developers to get a full understanding of the training data because the training data is released. So you need not make assumptions on the model performance, right? Because you have the training data, you can quickly work faster and you can create newer models. Okay. And the next thing is that by keeping these models and their data sets in the open, it enables researchers to learn and build from previous models and do work more faster. That's the idea. And because already this data set and other things are, already they have been collected and, the training code and other things are present over here, it requires less carbon for, full training and other things over here. That's what they're saying. Because you can fine tune these models. Okay, that's the idea over here. Now, they talk more about this data set in another paper. This data set is known as DOLMA, and DOLMA stands for, let me go to that particular, they have a blog over here which talks about this data set. Yeah, DOLMA stands for Data to Feed Olmo's Appetite. And here in this particular article, they have explained how they have created this data set and what is required in terms of efforts to create a fully open data set. Okay. So how did they create it? What are the issues? What needs to be done when you are creating a data set? What are these things? So that they talk over here. This is a very interesting blog which you can read through. Right. This is a technical blog where they explain more about this paper. Now, if you look at the high level, if you go to the paper and if you look at the high level architecture of this particular model, it's actually a transformer based model. Okay. This is actually the dataset paper. Where is the original paper? Let me go to that. Yeah. So if you look at this particular section, they talk about how they've extended the transformer architecture. It's a decoder only model. Okay. Based on Vaswani et al. So this is the original transformers paper. And here they talk about, how they have modified the architecture by, using a different activation function, which is SVGLU. They are not using any biases. So they exclude all bias terms from this architecture. Then they use something called non-parametric layer norm, rotary positional embeddings instead of normal position embeddings, absolute position embeddings. Instead of that, and they're using a modified version of BPE based tokenizer from GPT-Neo Extend. So this is about the architecture of the model. So that's explained over here. They also compare against various architectures like Llama 2 7 billion, OpenLM 7 billion, Falcon 7 billion, Palm 8 billion. They have not compared it with Mistral 7 billion or some of those kind of models. They are comparing it to Llama 2, Falcon 7 billion, Palm 8 billion. Okay. They have talked about the architecture over here in terms of the dimension, number of heads, number of layers, and so on. You can read it over here. This is about the distribution of tokens in the data set, basically, right? The GPT-Neo tokens, which is from these different sources, right? So that's what they talk about over here. This is in terms of millions of documents, okay? And this is the tokens in terms of billions. So close to 2.6 billion tokens which are present in this particular data set. Okay. Further details you can look over here. The models have been released on Hugging Face. So you can go and try out these models as well. They explain how to make use of this model. Maybe I'll create another notebook where I try out this particular, another video where I try out this particular model in a Colab notebook. Here they've compared the performance of this particular model, okay, on against say these 7 billion models like Llama 7 billion or Llama 2 7 billion or Falcon 7 billion, and they claim that this particular model's performance is much better than these models. Okay, that's why they say it is state of art on 7 billion parameter models, but they've not compared it to Mistral 7 billion. Okay, so they have released the models, the code, the training code is available on GitHub. They are doing instruction fine-tuned versions of these models, which will be released in some time. They're also working on a larger 65 billion parameter model. So we can wait for that to see how it improves performance when compared to other 65 billion parameter models. So there is this interesting Reddit thread where somebody has put saying that this model is being released, and one of the leads for this project is available over here. You can ask questions over here, and this person actually is answering these questions. So this Olmo 7B Twin is actually the model which has been trained on AMD hardware. So they also trained this model on both hardwares. Okay, so this Olmo 7 billion is a 2.5 trillion model which has been trained on 2.5 trillion tokens. And this twin is actually trained on your AMD hardware. So they have models which have been trained both on NVIDIA as well as AMD hardware. And this 2T stands for 2 trillion tokens over here. So this is the foundational 7 billion model. So the fine-tuned, instruction-tuned models will be coming out in the future. Okay, and this has been developed by Allen Institute for AI. Okay, AI2. Along with other partners like Databricks, Kempner Institute of Study for Natural and Artificial, Harvard University, AMD, and this Lumi supercomputer from Europe, because that was used for training. Okay, so this paper has interesting details on that part, like what is the training architect hardware. Okay, so they trained on both NVIDIA and AMD GPUs without any loss in performance on 2 different clusters. Lumi is the supercomputer where they used up to 256 nodes which had AMD graphics cards. Okay, and they trained on NVIDIA also using the Mosaic ML, basically from Databricks, Mosaic ML, their framework, and there you had 8 NVIDIA A100 GPUs. They had 27 nodes on this cluster where each node had 8 NVIDIA A100 GPUs with 40 GB of memory. So they talk about the carbon footprint of this model and other things over here in the paper. They talk about how they've computed this carbon footprint. So many other interesting things are present in this paper. If I were to discuss that, this would be a much longer video. But if you are interested, I can discuss this paper. I can also discuss about the dataset in separate videos. So this was a short video on truly open large language model Olmo from Allen AI. And this is a very interesting development, and I hope that more research institutes do follow this kind of a framework and release this pre-training data, because then what is the data on which this particular model is trained on, right? What is the training code? You can develop from that. So this is This will help foster research much faster. Okay, this kind of releasing of say truly open LLMs. I hope this video is useful to you. I'll be putting the links, all the links in the description of the video. Do check them out. If you like the video, please like, share, subscribe to the channel. See you in another video.